So we have my gas hot water heater here. It's fairly new, so I'm not going to be just out replacing it, but what I want to do in this video is in a reversible way convert it over to being an electric water heater. At the end of the video I'll talk about why I'm doing this, but for those of you that are just looking to do it yourselves, I'm going to go through the how first. So my idea originally is to put an electric heating, is turn the gas off obviously, and put an electric heating element in the chimney. If you guys aren't familiar, basically there's a hollow cylinder right down the center of this where the exhaust gases get burned all the way at the bottom and then rise up through and then out and exhaust in your house. So basically we're going to use that space to drop in an electric heating element that will contact the walls of this and thereby heat the water. So I went on to Facebook Marketplace and found an old stove listed for free, which I picked up, pulled out the heating elements. These literally just pop right out. You can see I've got 3 small ones and then 1 big one. So yeah, I'd recommend looking at Craigslist, Facebook Marketplace. You could also go to your local scrapyard, and you can probably find these for free. I found multiple listed. And then what I'm doing with the rest of the stove when I'm done is I'm just going to take it to the recycling scrapyard, and I might even get paid for it. So we're going to measure the resistance of these, so we know approximately how many watts they're going to put out. The formula you'll use is V squared divided by R being resistance, V being the voltage, which should be 120 volts for our application. So I'm going to test this big one right here. Hopefully you guys can, hold on. Here's a big one. You can see I'm getting exactly about 28 ohms for R, ohms. So when you do the math, that comes out to be about 520-ish watts of power that we're going to put out. This smaller one over here you can see is about 45, 46 ohms. So that's going to be less wattage. But yeah, so this one's about 500 watts. This is what we're going to work with. So we're going to try to reshape this to fit inside the chimney. So there's a little bracket right here that I'll probably have to just cut and then try to reform it. So you could also just obviously buy an electric heating element. That's obviously an option. But we're going to do some trial and error with this and see if we can make this project as cheap as possible. So the first things I want to do is just test it. So I got this random, this was a power cable for a computer that wasn't being used. I cut off the end. So it has 3 wires. This one's the ground, it's the green one. I'm not going to use that. So I cut off the end, I shortened the ground. I'm not going to use this, I can tape it over. And then I just stripped a little bit off the ends of the other 2. And so I'm just going to test it in a safe place where I can watch it. So I've got the heating element over my current stove. I'm going to plug this in and then just use some clamps to attach the wires, and I'll show you in a second. Here's just a look for reference. Hopefully you guys can see, but I'm hitting over 600 degrees with this infrared thermometer. So using my multimeter, you can see I'm running about 4.4 amps at 120 volts-ish. So that's, I'm getting about 530-ish watts of power right now. So yeah, cooking pretty good. So you can see I just used the clamps just to hold the wire in place. I just don't want to do anything permanent just yet. And I'm just going to let this go for a few hours. Just make sure no fires abruptly start or this wire doesn't start to melt. I'm just going to watch it here for a while. So we're going to start kind of dissecting the hot water heater. So first thing, like I said, we want to make sure this knob, the control knob, is all the way to off. And then I just rotated this valve for the gas line 90 degrees. So it was this way, now it's down and it's off. So then we're going to come up here. So this is the chimney stack right here. So we want to get rid of this. So there were 2 screws, which I already removed, just a regular Phillips head. And then the rest of it, you should be able to kind of, it might be different from setup to setup, but it's loose. So it just takes a little bit of finagling. There you go. And so I've got this stack off. Let me just remove this. And so you might want to be careful. This might be hot right now if it was recently on, but hopefully this gives you guys a good view of what's down inside. So there's this metal, it's kind of a zigzag Z-shaped thing that runs down the middle of the chimney. The point of this is to, 1, slow down the exhaust vapors as they're leaving, and then trap some of that heat and kind of, again through conduction, touch the walls of the chimney, and then just spread that heat through the water. So unfortunately, you'll see in a second, let me just pry it out and show you guys. So I'm going to pry this out. again, making sure it's not so hot that I can't touch it. This is what it looks like. And so unfortunately with mine, it's too long to get all the way out. So I'm going to be forced to basically work around this thing. So I'm going to try to wrap my new heating element kind of around in the white space. So if you could get it all the way out, even better. Just take this thing all the way out, because ideally we want our heating element to get as far down in there as possible, because the hot water is pulled from the top. So you would ideally want to heat closer to the bottom of the hot water heater. So for us, we're just going to get a vice grip real quick and hold it in place so we can start kind of molding our heating element around it. Got my element just lightly gripped in the vise. I'm going to just use a Dremel to cut this little bit right here just so I can more easily shape it. So my original ambitions were a little cut short. I found the stove element a little bit too hard to manipulate to like kind of wrap it around here, so I'm going to end up getting this out. So obviously I could lower the hot water heater, but I think that's more work than what I intend to do is just take a Dremel and make a cut. So I've got it held with these vice grips so the bottom piece doesn't fall down. I'm going to cut right above the vice grips right here, remove the top piece, then remove the bottom piece. And then I'll just use a little piece of sheet metal and some sheet metal screws to attach it back together when I want to revert this back to gas. Here's that insert inside the chimney. It's funny because you can see I had it gripped down here. I was only a few inches away from being able to get it out. It's only a couple inches longer than the amount of space I had above there. But I did to reattach this piece. You can see this kind of flexible sheet metal adds a bit of flexibility, so now I can take it in or out without having to disassemble or reassemble. Pretty nice. But anyway, now let's get a better picture of what's inside. So hopefully you guys can see right down to the burner. So I'm going to reshape. Should be a lot easier now to try to reshape one of these. I've just been kind of twisting it. I tried a brake line tubing bender, couldn't really get that to work. I was kind of wrapping it around this pipe. It was kind of helping me, but it's definitely a struggle, but it's doable. Here's sort of the final design. You want it to touch the circumference of the chimney, but not too much, so that it's like scraping. You can see I got a few scrapes here, and then keep both ends separated but near the top. Yeah, and so I think we're ready to start testing it out. I want to talk about timing and how we're going to control this, because obviously we don't want to just leave this plugged in 24 hours a day. I think that's excess. So at first it's going to be trial and error, but anyway, we need to be able to somehow control the time. So simple way, you can buy one of these timers. They're probably only $3 to $5, and you just press down what times of the day you want it to go on. So obviously, like if you're taking showers in the morning, you probably want to turn it on a few hours before you take showers, and you just plug this into the outlet and then the power cord into this. However, I have this Emporia smart outlet. I'll show you some pictures on my phone, but my phone can completely control this. It's connected to Wi-Fi. You could buy this, probably $20. It comes with a set of 4 of them, so I can put it on a schedule. So obviously I'll have it running in the morning, and then maybe a bit before dinner, maybe a couple other times throughout the day for an hour or two. It's going to be some trial and error until I find what seems to work best. Before I go any further, I've got it configured for a test. So I'm letting it run for 3 hours and kind of stand nearby just in case. I've got my fire extinguisher here just in case, and then I'm just watching it, measuring the temperature, pulling some hot water heater, seeing how it goes. This isn't going to be my final setup, but I just wanted to make sure nothing too crazy happens, and I don't have my thermal fuse yet. I'll talk about that in a bit. Home Depot and bought this Cero wire. I guess it's ceramic. It says it's for appliances. It says it's rated to 105 degrees Celsius. So we're going to start with this. You could alternatively try to rip some of the wire that was in the stove that came with it. But anyway, so I took a little piece of sheet metal, whatever you got, to kind of act as a cap for this chimney. Get some light. So I've got another temporary setup. So I attached the Cero wire. I didn't solder it yet. I'm still in the test mode. So I attached the Cero wire to the heating element. I drilled a 5/8 inch hole through this little sheet metal just to cap it to kind of retain that heat. And then I've got it plugged in. And so again, fire extinguisher nearby, and I'm just going to run this while I'm home. I'm actually going to go upstairs and get my smoke alarm too and put it next to this, just so it's even faster response if something does happen. And again, we're just testing it. So I did have to buy a new circuit breaker. I currently have a 20 amp breaker, and the element alone wasn't tripping it, but I have a bunch of other things wired onto it. For instance, this outlet that I use here for tools, and then the outlet I have outside, which powers the chicken's water heater. So all that together, when it would all run, would throw the breaker. So I got one instead of 20 amps for 30 amps. So in other news, this element comes with 3/8 inch spades, and I couldn't find a 3/8 inch spade connector at Home Depot or Lowe's. I could buy it on Amazon, but I think it's going to be fine. So what I'm going to do is I'm going to cut, instead of just these tiny wires that I was using to test, I'm going to cut this Serro wire again. It seemed to work, didn't melt or anything. So I'm going to cut about 2 feet for each length, obviously leaving some at the top where I'm going to tie a knot to kind of hold it. But yeah, instead of the spade connectors, I'm going to kind of do what I did and just wrap it around there and then solder it. So I've soldered them on so that way they hold. I just want to make sure, like basically I just don't want this thing to fall in there, and you can see it's holding pretty well. I even attached a tiny metal wire that I tied a knot in just in case, just so that'll come through the top too, just so I can, I just don't want it to fall down the chimney and not be recoverable. But so anyway, so I'm going to put this down, and these should come just through the top. So I'm doing one more test, and just by the way, what I ended up going with, I'm using about 12 gauge wire. The Serro wire is for sure 12 gauge. I'm not exactly sure what the power cord is, but it's similar. And I ended up going with the smaller heating element, the one that had the 46 or 48 ohms of resistance. So as you can see, so I have the lead weight to hold the chimney cap to trap the hot air and again make it a little more efficient. I tied a knot again just in case so nothing falls down. My backup safety string is just wrapped around the hot line just in case there's any heat transfer. Obviously I'm getting real theoretical here, but so I'm doing one final test. The last thing is obviously I'm going to wire in a thermal switch, but that's about it for now. And yeah, it's drawing 320 watts, and I'm still going back and forth between the schedule, figuring out how much it needs to be. But anyway, so right now my heater is probably sitting, let me back up the camera, I would guess probably right around in here. And so obviously the bottom's all the way down here, but this is also a 50-gallon tank, and just for your awareness, there's only 2 people in this house living here, me and my wife, and we don't use that much hot water. So again, if you have a bigger family, you're probably going to need to adjust the schedule, make it run longer, or also maybe use that bigger heating element. So I'll include a link in the description. Here is the thermal switch that I bought from DigiKey. They also have thermal fuses. So the difference, a thermal fuse, once it breaks once, it's done, you have to replace it. A thermal switch is resettable. So basically, this switch is designed, if it reaches a temperature of 80 degrees Celsius, or I think, sorry, 75 degrees Celsius, it will switch itself off automatically. And once the temperature goes back down to, I think it's 60 or 65, it'll switch itself back on. And so it came with this little mounting ring at the bottom here, and then there's the standard 1/4 inch spade connector. You can see I have one on. And so all I'm going to do is, in either wire, just splice this in, and I'm going to attach it to the outside of the tank like here, and just crimp the wire on spade connectors and connect it. This is just an extra backup, basically, make sure it's not getting crazy hot, so it'll automatically turn off if it gets too hot. The last thing I'll say, so that smart monitor that I was working was really having trouble. Like it didn't want to like kind of respond on the fly. I honestly don't know why, but so I ended up going back to the simpler version. And then lastly, I found there were too many variables so basically me and my wife might not always have like the most regular showering schedule. Sometimes we shower in the morning, sometimes at night, sometimes like my wife might take 2 showers in a day if she works out. So I'm going to actually I'm going to make it a separate video, but I'm going to end up regulating this thing with the temperature sensor. I think I'm going to mount the temperature sensor on the hotline and do some kind of temperature calculation adjustments, but that'll be a whole nother video. Last thing here is I'll get into the why I've done this project, and this is basically the why. So if you've seen my videos, last September I put in these solar panels, and I live in Alaska, so we get a lot of sun in one half of the year and not very much sun in the other. And so what ends up happening is in one half of the year I basically get way more solar power than I can possibly use, and both my furnace and my hot water heater run on natural gas. So my original thought was that this year I might put in some some hot water heater, like solar powered vacuum tubes, those evacuated tubes. But because we're in Alaska, my roof is actually separate from my house, so I can't just run that water that I would cycle through the solar tubes straight into the house. It would have to run down the side of the house, which is also quite exposed, so it would, and because it's not that warm here, all of that tubing, which is not evacuated, all that piping, would make it get very cold on its way down to transfer that heat to my hot water heater tank. And my hot water heater is also very new, so I didn't want to just replace it with an electric one. Plus, it's going to be cheaper for the 5 months out of the year where I'm not getting enough sun to switch back to gas. So that's why I wanted to reversibly change it over to electricity. And so far so good. So it's running on electric power, and it's going to be like that 7 months out of the year, March through October. Oh, and one other thing, it also has to do with my electric billing. So I get my electric bill is just the total net fee at the end of the month. It doesn't matter time of use, etc., etc. So basically, it doesn't matter when I run my electric hot water heater, or as long as over the course of the month it still comes out to a net zero, I'll be good. And every month, so even in March, which is like low sun, I was 80 kilowatt hours more generated than used. So that's why I'm doing this. And if I run that hot water heater element that I have in there for 6 hours a day, which I think might be more than I need, that comes out to 2 kilowatt hours for the day. At times 30 days is like 60 kilowatt hours. So even in March, I would still have 20 kilowatt hour surplus. And because I'm selling it back to the electric company for such a small amount, that's why basically. So saving me some money, saving some gas, pretty cool.